We'll now look at an example involving the counting principle. At Old Navy, a supply of solid colored t-shirts has just been received. The t-shirts come in the following colors: green, blue, white, yellow, and red. The floor manager decides to display one of each color t-shirt in a row on a shelf. Part A of the problem asks us, in how many different ways can he display the 5 different t-shirts on a shelf? So we want to approach this problem by thinking of having 5 positions to fill. In other words, having 5 spots on the shelf where we're going to display a particular t-shirt. In the first position, here on the left, he can select any of the 5 t-shirts. So he can select green, blue, white, yellow, or red. And so he has 5 color choices. In the second position, he can use any of the 4 remaining colors. So in other words, if he had used green here, then green would be eliminated, and for the second spot he would be left with blue, white, yellow, or red. So 4 choices. In the third position, he can use any of the 3 remaining colors. So if he chose green for the first spot and blue for the second spot, then he has 3 color choices remaining for the next spot. We continue in the same fashion, saying that he then would have 2 color choices for the 4th spot and 1 final color selection for the 5th spot. The counting principle requires us to multiply these numbers together. So 5 times 4 times 3 times 2 times 1 equals 120 different ways to display the 5 different t-shirt colors on the shelf. For part B, he wants to place the blue t-shirt in the middle. And the question asks us, in how many different ways can he arrange the t-shirts? So our color choices remain the same. We have, I'm just going to jot them down over here on the side. We have green, blue, white, yellow, and red. And we still have 5 positions that we need to fill using the 5 colors. So I'm going to go ahead and draw 5 blanks. We begin by looking at the requirement that is made in the problem. They tell us that we want the blue t-shirt to be placed in the middle. So when I'm thinking about the number of choices I have for this middle position, I only have 1 choice. It has to be blue. So I can go ahead and cross the blue out. Now, once that's done, let's go back to the first position and start filling in from left to right. So how many color choices do we have for the position on the far left? It can be green, it can be white, it can be yellow, or it can be red. So we have 4 color choices for that position. Supposing that we selected green, as we move to the second position, we only have 3 options left. The second position can be white, it can be yellow, or it can be red. Supposing that we picked white, that would leave us with 2 remaining choices for the 4th position, and it follows that we would have then 1 remaining color choice for the last position. So 4 times 3 times 1 times 2 times 1 gives me 24 different ways to arrange these t-shirts if we need blue to be in the middle. All right, so part C, the final part of this problem, says that if Billy wants the white t-shirt to be the first t-shirt and the blue t-shirt to be the last t-shirt, in how many different ways can he arrange the shirts? So we're going to go ahead with our 5 blanks to represent the 5 positions. We know that we want the white one to be first. And so when I look at my first position, I only have 1 choice because it has to be white. All right, so I'm going to go ahead and mark off the white one completely. We also know that we need a blue t-shirt to be last, which means when we look at the last position, we only have one choice. It has to be blue. So that eliminates the blue choice. Now let's fill in what's left. For the second spot, we could either use green or yellow or red, and so we have 3 choices. Supposing that we use green, that would leave us with 2 choices here, yellow or red. And supposing that we use yellow, that would leave us with 1 choice for our 4th position. So 1 times 3 times 2 times 1 times 1 gives me 6 different ways to arrange the shirts.